All right, so looks like we have some people here getting there. Welcome to class 2 of our programming. Nice to see all of you on this really nice day. Everyone's stuck inside, sadly. So today we don't have that much logistical, stuff to take care of. But I do want to start the class off talking about the results from the post-class survey that I sent, or that you should fill out for your attendance. So thanks everyone who did fill out kind of the open-ended questions for those. So after every class, I put the result, well, once I get enough results, I put them on the class website. So this is our class website. This is class 1 page. And so at the bottom are the post-class surveys. So I did want to note another thing about the recording. So in Slack, I posted the Zoom link for the recording, and you're all welcome to use that if you like. That's going to have like my video, I think maybe the chat window and the like live transcription in there. That's one option. Or I also processed it and put it up on YouTube, so you can go there. And if you click this, it will play, or you can watch it on YouTube. One thing I tried to do was make like little chapters. You can see it in the description. So if you kind of know the general thing you're looking for and you just want to look for one section, you can click on these and it will take you to that part. Though I didn't put that many in, but hopefully that's a little bit useful. And you can also turn on captions for this as well and kind of speed it up as though I don't talk fast enough, probably. So I'll do that for each class. I tried really hard to not show any faces or names or anything. So hopefully I cut all that out. And that should be up there the next day or two for this class as well. I lost my chat window. Mind just to make sure. Okay. So in terms of like muddiest versus clearest points, as expected, I kind of got the sense that a lot of you who have taken math biostats classes, most of it was review, except for maybe the for loops part. And then there's some people who are brand new to R, and so it's going to take everybody a couple classes to get on like the kind of similar level. And I know we kind of rushed a bit of for loops at the end, and I do want to start a class with that again to talk about it a little more. One question was that, like, why would we want to do for loops? I didn't really get into the true motivation behind it because we haven't really gotten to more advanced basically data manipulation, right? We've only talked about vectors. We're doing really simple stuff right now. So for loops aren't really that useful in this scenario. Once we start doing more complex data manipulation, it'll become more clear why we would want to iterate. That's sort of like the real reason why we do programming is we make our lives easier. So for loops can make our lives easier if we do the same task over and over again over maybe a list of data frames or something like that. So we'll talk about that in probably maybe next class. And then another question was about a specific question, which actually I think I'll just go over when we're going over the code, which is why are we doing this line? Why are we tacking on my pet onto all my pets? So I'm going to talk about that when we go over it in a minute. And so if you asked a question, I tried to answer it specifically. I think I got most everybody's questions in here. So check that out if there was something you wanted to know. And if you do have more specific questions, definitely reach out to me, or you're welcome to ask questions during class or in the chat, or even private message me in the chat. I'll try to look at it during breaks. And so for the most part, it seemed like a lot of it was pretty clear. And I think things will get more clear as we start talking about data and how we use data frames, because that's more realistic, related to what we're talking about related to what we do in statistics. So any questions about that? The other thing to note is on class 2, I try to put up the slides. I think I put them up last night. So there's slides here. There's not really that much on them. We're mostly going to be working in R today, but if you want to open those, there's the link. and that's all available to you. So today we're going to talk a little bit more about for loops. And it's something that we're just touching on now, and then we'll come back to this idea of iteration again, I think in like class 4 or so in a couple weeks. We'll talk a little bit more about Rstudio projects. That's something I want to sort of touch on often until we kind of get used to using them. We'll talk about what is tidy data, and we'll have a ggplot intro where we just do kind of basic stuff. We're going to learn more advanced ggplot plotting later, so that's to come as well, because that's a very powerful tool. And so we talked about muddiest, clearest points. We talked about YouTube. And so let's go to class 1. Let me get my folder. So I told you all that this folder was updated on our Slack message to everyone that now there's a part 2 and a function of the week. And so if you downloaded those 2 folders from Dropbox link, you should have these, but then you should also still have your part 1 folder somewhere. Hopefully I have them all together because this is how I built it, but you might have it in a different place, and that's fine. So I'm going to open up my part 1 folder and then double click on my our project file, just because that's going to open Rstudio probably on one of my screens. And let me hide this. Okay. So one thing I want to mention is that when you open up Rstudio, looking at my environment, everything is empty, right? I haven't run any code. And so that's one thing to remember when you open up R Markdown. And I know I want to go down to for loops and just running code down there. But I need to be careful, because if I'm doing any kind of data manipulation, or if I've loaded any packages, which I'll talk about today, that code hasn't been run yet. So R is going to let me run this code right here, but it tries to help me out. Actually, it automatically runs this code. And so where is that even coming from? If we go all the way to the top, at the first, right below this YAML part, which defines what our Markdown output looks like, and in between these 3 dashes, is my first code chunk. And this has a code label. It's called setup. I don't think it needs to be called setup for this to happen, but I think it automatically just looks for the very first chunk and then runs that code. And so what this code is doing is telling me I want my I'm setting this option in knitter, which says echo equals true. So that means when I press this knit button later, all of my code is going to be shown. So that's the echo part, echo my code. And then the second line I have done is loading a package called vembedder. And so that was one that loads the YouTube videos in the Markdown. And so in class 2 section, you'll see that we have more packages to load. So that's nice. R tried to help me. It ran this and then ran the chunk that I asked for. But if I had loaded any data or changed any data in between, it won't run that until I tell it to. So one way I might round that is if I do know I want to start down in the middle of my Markdown document, I'll scroll down to where I want to be, and then I'll push this button, which is like a sideways down play button, or next button or something. And so this says, it should, yeah, if you hover, it tells you it's going to run all chunks above. And so assuming I'm not doing anything too time consuming or complicated, that should run pretty quickly. And it did, and you can see all the output here. And so now I'm safe and secure that everything is set up how I expected it to when I wrote this code. So just keep that in mind. R Markdown is very handy, but it does have things you have to just be aware of. And one tip I think I didn't mention is this, that's like outline here. I use this a lot, especially like for something like this, where we have a lot of sections and I just can click on the for loops. So that's nice. You should have this little button here. And the other thing that I don't use that often, just because I'm so used to writing it down, but if you're new to Markdown, like this text type that is here, you can click this little I think everyone has this. Hopefully this isn't like a preview special thing, but you should have this button that will turn all my text into essentially what it looks like when you knit it. And so if you just don't want to deal with the Markdown syntax, you can work in here. You can see it has like bold and links and all kinds of things. It's kind of like working in Word. You can change headers and all that. So I turn that off. I find it a little distracting, but it's your preference. However you want to work in our Markdown is up to you. So lots of tips, lots of nice things in our studio. All right, so yes, okay. So going back to for loops, then let me go make this bigger and come back to the slides. So we showed these slides last time. Ted drew these little pictures. And so the idea behind for loops is that we have a vector already defined, pets. And so you did this in your homework where you had a vector of numbers. In this case, it's character vector, but we had in the homework numbers. And so for each element of that vector, we do something. In this case, we're printing the element. And that element, that indexing element is called pet. And so the first one is dog, so we print dog. The second one is cat, so we print cat. And the third one is mice, so we print mice. For loops can get a lot more complicated. This is kind of a cute, kind of philosophical, not real code example. This is the idea that if you had, say, a vector of, let's just make pictures of shapes, and you want to iterate across those shapes, this actually incorporates something called an if-else statement. So this is something we'll see later and we'll learn a little bit about in more kind of advanced data manipulation situations, but you can read it because we all have this idea of if we do that, if something, then do that. So if the shape is a monster is equal, or if the shape of the monster is equal to a triangle, then we say their style is monster plus sunglasses. Otherwise, else their style is monster plus hat. And then you print that monster style, which is basically the stylized monster, I guess. So this is like a cutesy way of thinking about how we iterate through elements. You can see all the elements are here, but they've been changed. They've been given sunglasses or hats, depending on whether they are a triangle or not. And that is essentially the idea of what we're doing. We're going through a vector, doing something to that vector, whether it's printing it or changing it, depends what your code looks like. So going back to here, we talked about these examples. So I want to get down to this example again, which is essentially very similar to your homework question, except we're dealing with characters. So this is our vector pets, dog, cat, mouse. I think it's a little different than that image. And so this vector, all my pets that I'm using to later save my work, I've made an empty vector. There's other ways of creating empty vectors. This is the kind of the way I do it, but there's other possible code options, so just keep that in mind, but this I think is simple. And so the reason, if I run this first line only, and then I output all my pets, you can see that it's null. Null basically means empty in our speak. And so once I start going through my for loop for pet in pets, I'm creating this new object, my pet, which is the pasted version of Jessica's pet. And so what I'm going to show you is that one way to see what's going on is to actually just use these print statements to print every time this is run. So I'm going to run this whole code chunk, push the little play button, and you can see for pet in pets, I've printed what my pet is. But still, we can also look at all my pets, and all my pets is a vector class character, and it has a length of 3. So all my pets is the vector of these 3 things, which is exactly what we wanted. The question in the the survey was, what happens if we just say this? Actually, before I do that, let me also print out all my pets just so you can see what's going on here. I commented this out, so it's no longer printing my pet. I'm gonna print all my pets one more time, doing the exact same thing. And so you can see actually that it's getting bigger. The first iteration was Jessica's dog, the second iteration was dog and cat, and the third iteration was all three of them. And so the question was, why do we have to put C, all my pets, comma, my pet? And that's because otherwise it doesn't know to add it on. This isn't adding anything on. You have to kind of think as C as like a combining function, combining two things. And in this case, it's combining the old vector with the new element. And so if I were to run this, now we see that all my pets is actually just one item at a time. So it's dog, cat, Jessica's mouse. And if I were to print out what is the final value of all my pets, it's only the last one, only Jessica's mouse. So basically I've redefined all my pets as my pet every single time. I've just rewritten exactly what it is. And so we do need this part here because that's concatenating or combining the old vector with the new thing we want to add at the end of it. And so just so you can see, running it again, here's the printing part from the inside the loop. And then this is the all my pets that I've printed out at the end. And related to that, just so you know, the C function, let's say apple is 25, and then pear is C25. These are exactly the same. You don't need the C when you only have one element. So if I say, what is apple? 25. What is pear? 25. They're exactly the same, a vector of length 1. So the only time you really need a C is if I wanted to add on 2 or more elements. So now apple is still 25 and pear is the vector of 25 and 26. So just keep that in mind. These are the same. You can do whatever you want. Similarly, my pet, or yeah, let's do pets. That is also the same. Pets was a vector. Putting a C around a vector doesn't do anything. It's exactly the same thing. So those are identical. We don't need the C there. We only need C1 for combining. Any questions about that? One more example, I think, before we move on to class 2 is this numeric example. This is harder because I've used this idea of indexing along the length of my vector. So I have 2 vectors. In this case, cars, MPG, so essentially miles per gallon, and then cars, miles. We can think of that as the number of miles of the 3 cars driven per day. So 2 different vectors. And I want to know how many total gallons did these 3 cars use. So the way we would do that is we want to index along both of these vectors at the same time. And so there's a function called seek along. Let me run cars MPG, cars miles, make an empty vector. So this seek along creates the vector 1, 2, 3. I could have just said index in 1, 2, 3, or index from 1 to the length of cars MPG. Many ways to do this, but I did want to just introduce this function in case those of you who are using art haven't seen it before. It's pretty useful because it can change along with your data. And so this is saying for index from the values 1, 2, 3. And so the code that I'm doing here is dividing each element of cars miles by each element of cars MPG. And the index says I want the first one for the first iteration, the second one through the second iteration, and the third one through the third iteration. So I'm gonna add this print ng and print cars and gallons just so you can see what's going on. And so let's run this thing. So for this was the first pass, and we can see the first car had 0.5 total gallons, and that makes sense, right? if it's 20 miles per gallon and we drove 10 miles, then we used half a gallon. And then in the second pass, the second car used 0.0333 gallons. And now we can see that print cars and gallons is length 2. It's added those two pieces together. And again, the third pass, we have a new value for ng, and then we have 1, 2, 3 elements of our vector. So that is our final vector. Cars and gallons is that vector of 3 numbers. Oh yeah, it's here too. So this example shows a way to use essentially the vector index. So you can have multiple vectors or data frames or whatever, and use that same index so that you're going in parallel essentially along 2 vectors or multiple vectors. And so that's a really common use for loops, which I use often. And so how many total gallons did they use? We can add them all together. Total is 1.66 with sum, and we have the full cost of those cars, I guess. Another question was, can you ever get stuck in a for loop, like infinitely? And I can't think of a good example, but I will say, trying to find something that's, I'll just make it up. I will say that there are many instances where you might end up with an error halfway through or something. So let's say my vector is 1, 4, 1, 5, -2, 3. So I have a vector of numbers, and I want to go along this vector. And I'm just going to hard code it 1 to 4 for my simplicity example. And so let's say I want to print log of my vec index. Actually, let me just call this something, my log. I'm not good at coming up with the variable names, as you can tell. Something simple. I just want to calculate the log. I think the default is the natural log of this vector. So what happens if we run that? We actually get a warning. I was expecting it to give me an error, so that's not actually a good example. But sometimes, instead of a warning, you would get something that's like, says an error, you can't do that. And it will be kind of cryptic because maybe you don't even have a print statement here, and it's just doing this, and you end up with an error and you don't actually know what happened. And so by printing, I am able to see what is going on. And I actually often print, my keyboard is all sorts of messed up. I print often lots of things in my for loops, just in case. Oh, there's an error actually, but not a good one, a spelling error. I print a lot of stuff just so I know what's happening. Sometimes I even just print index. And so this really helps with the debugging. And so we can see this was the first pass. The index was 1. It was able to calculate it, and it was 0. The second pass was fine. And the third pass is actually what gave me that warning. It's because I had a negative number. And I tried to take the log of a negative number. I didn't like that. So it gave me an NA. I really thought that would be an error. If it was an error, it would just quit. Like it would stop that for loop immediately. I should have come up with a real error example, because if it had errored, it would have stopped at index 3. And so I could have, if I printed index and there was an error, in this case, it kept going, so it was a 4. It would actually tell me where it stopped. It would say index was 3. And so that's just a kind of a very simplistic debugging tool that we have for something like this. And we'll use it again, this idea of printing out what we're doing. We'll use it again when we learn how to create our own functions. There are like really like sophisticated tools in R that you can use for what we call debugging, figuring out why there's a bug or an error. And those are very powerful. But the most simplistic, easy way that is just kind of a default in my head is to print as much as possible, so I know what I'm doing and what could be seeing my error. So to keep that in mind, I'll try to think of a better error example and a real one. Any questions about that? So all of this has been quite an educational exercise because we didn't actually need to do any of those 4 statements. R is really powerful in that it actually does something called vectorization, which means that a lot of the functions in R are vectorized and you don't need to use a for loop. So we'll see situations where we do need to do some kind of iteration like this later when we have more complicated examples. But in these really simple sort of examples, we can actually use math and other functions on vectors. So remember, cars miles was a vector, cars MPG is a vector. And so if I run the cars miles divided by cars MPG, I get the same thing. I get a vector of length 3 that tells me how many gallons I used. And so super simple way to do it, very effective, similar with pasting pets. In my for loop, I pasted 1 at a time and that worked, but it was a lot of code for something that I could have just done in 1 line. Because paste is a vectorized function, which means that you can put a vector in as an argument. And so a lot of R is like that, but there are a lot of functions that are not. And so you will need to use a loop or another kind of iteration, which we'll talk about when we get to the per section in a few classes. So just keep that in mind. It's worth trying. If you want to do something over a vector, just try it. It might give you weird behavior, in which case then you know it's not doing what you want it to do. All right, so if there's any questions about for loops? Make sure I just didn't miss anything. Okay, so now let's switch over to class 2. Before we do that, I want to show you, for those of you who don't use Rstudio projects, just like another tip here. So right now I'm in my part 1 folder, which is a project. You can see that. You can see my file path here. Hopefully, I don't want this here. Hopefully you can see my cursor. It's big enough, but it's showing you it's in my Dropbox, it's in the work folder, I have a repos folder. It's all in here. And if I click on these folders, I can kind of navigate around. If I click on this little octagon of an R, it's going to take me to my root folder. And so if I want to open up a new project folder, there are many ways to do that. So let's say the one way you can do that is click up on the right-hand corner. There's a button that's this whole long thing, and it says new project. That's one way to create a new project, or open old projects you've had before. You can see I have a lot of ones that I've used. Another way to make a new project is this little button here, which I always forget about. I kind of do it the old school way and go file, new project. I don't know why. So let's do that. So you all should have downloaded the function of the week folder, but I didn't put a project in there. And so I'm going to create one. Hopefully I didn't do it for practice, but if I want to say create a new project, you can either start in a new directory, but I know I have a folder, it has some files in it, and I want to make that an Rstudio project. So I'm going to look for that folder, hopefully this one. And so this was the function of the week folder that you downloaded from the Dropbox. It just has 4 files in it. There's no .rproj file. And so I'm going to say open, and that is going to open this folder as a project. And one thing you can do is click this open in new session. You can actually have many Rstudio windows open at one time, which I get in the bad habit of doing. So to remove my bad habit, I'm actually going to close this one. Well, I'll show you. Right now I have 2. It's possible. And you can even have the same project open twice. I sometimes do that if I have two documents I want to be running and they don't listen to each other. What you're running in one window is not being done in the other window. So it's kind of like you have two environments. So that can get a little messy. So just be careful. But I'm going to close my part one and I'm going to bring up the function of the week. So I did mention last class that part of your grade is this function of the week. And so this folder has everything you need for that. I'll show you this template. This is what you will use to write up your short little blurb. You probably have all looked, or most of you who have looked at the website to see examples, and they've all used this template, very short. You pick a function, and I'll show you the sign up sheet in a second. You pick a function, you can use this data, you can use whatever data you want. Basically just answer two questions. Show a short example, maybe explain what that example does. And then like a short one sentence, was this useful? Is it helpful? Can you imagine a situation in your work or in life where you would use this? Or is it just sort of not that relevant? And I'd say most functions are probably useful, but maybe you just haven't run across the situation where it is, or maybe you know of a better way to do it. So the sign up sheet is here. Actually, I think I have it open here. It's at that link. You would put your name here and the week you want to present. I'm not going to restrict any like how many we have each week. We'll do it at the beginning of the class, less than 5 minutes. Just a very brief hello, this is the function kind of situation. I did leave the functions that people presented last time because there's a lot of really good functions in here. So I just put an X by them. You're welcome to take that again. Just make sure you're not like totally copying what they did, basically. Just come up with your own example and your own way of thinking about it, and that's fine. But feel free to look at their version as well. Mostly because I want, this is a learning experience for the person presenting, because when you teach, you learn things better, but it's also a good example for everyone else to just be exposed to more functions and not have me explain all of them to you. So sign up whenever you want. Feel free to meet with me if you want to talk about it, but you don't have to. This part thing here is giving you an idea of kind of when these sorts of ideas will be introduced. So kind of ideally you would present after class 5 for these, but you don't have to. You could do it earlier if you feel comfortable explaining it earlier. So we might have maybe no functions of the weeks 1 week or 5 the next week. So just sign up for weeks 3 through, try to do it by week 10 if you can. I feel like it's better to get it done. And definitely let me know if you have any questions wherever offline, and sign up whenever you like. And so each week we'll start out with, we'll still do the muddiest points, but then we'll also have this short little presentation by everybody in the beginning and then go on to our markdown stuff. Any questions? We'll show you, this one was Ted Ladares, the professor last year, his example. So you can look at his. This example is using a function called slice, which is essentially a way to select or show parts of a data frame. And we will maybe talk about that a little bit today, but he shows 2 examples and then says, it is useful, but I wouldn't use it every day, but it could come in handy. So kind of a non-committal answer to that. So on that note, let me close this and open, close this too, and go to the slides. So yeah, before we go to part 2, I'll just briefly mention, actually, let me show you function of the week. Now you can see the files, has the same files before, but now we can see in our project file. So if I wanted to open that project, I would just double click on there. So that's given me that option. And what time is that? let's talk a little bit about projects and then have a quick break. So we have talked about file structure a little bit in that we have up until now kind of just put everything in the same folder, right? So part one had all of these files. It had the assignment. It had part one RMD. I copied and pasted it and then like duplicated it and started working on my own version. So I have that. There's an R file, which just has code in it. Actually was this other bonus RMD using a package called Swirl. If you looked at that, it's actually a fun package that's like an interactive way to learn R. So if you want some extra practice using R, I would encourage you to open that RMD and run the code inside of it. It's kind of a fun gamified way of learning R. And there's an image folder, but that's mostly for my own purposes, but it was being used in the RMD. There were pictures that were inside that image folder. But usually you have something more along the lines of what data or what part two folder looks like. Because when we're working with data, we often have some data files. So this is in the data folder that's inside the part two folder, right? We also have another image file, which has a lot of files in it. And again, we have a part two and then a part two assignment and an applied, which actually is generated by the RMD. And the idea behind the RStudio project folder is that you have this like home root folder. You have your main folder that holds your other folders, subfolders like data and image, and you have your RMD files. And once you knit those RMD files, you get output, which is going to create HTML files by default, or PDF or Word documents, depending on your settings. And it might also create, I should have drawn another box of like output data or output figure images or what other kind of output is being generated by your code. And the idea behind RStudio projects is that your home base or your root folder is only aware of what's going on in here. You could totally move this folder around. Part two, I could put it on my desktop and all the code would run again. Everything is relative to your project folder. So when we start loading in data, it's good practice to use RStudio projects, because then when you call upon a data file like this TCGA data, which we're going to use, you'll just use this path, data / I guess depends whether you're on a Mac or PC, and then the name of the file. And if I wanted to source an image inside my markdown, I would say image / whatever the name of the image is. So these RMD files, being a part of that RStudio project folder, know that the relative file path is relative to that main root folder, and it sources all these folders and files that it needs. And so it's good practice when you're first beginning is to put your markdown files in the RStudio project folder. If you start making a folder that's like code and you put your markdown files in there, it's going to get harder. And I don't want to get too much into the details now. We might talk about this later, but there are ways around dealing with that. But as a kind of a beginner thing, just make sure if you get kind of weird errors about can't find this file, can't find this image, make sure that your RMD is in the same folder as the .rproj file. And that's so it knows exactly where to look and what to look at. So let's open that now. Okay, so part two, and remember, it's a good idea to just like make a copy of this. So one way to do that is to open it and then file, save as, and I'm going to call it underscore my last name, and then scroll way up. You can put your name here, see what you like. Okay, so hopefully you have all downloaded this and already knitted it, because I put that in Slack as like a thing to do before class if you had the time, because here I am loading many packages. And if you hadn't installed them already, this code will force your computer to install them. So if you're having trouble you're getting weird errors, it might be because you haven't run this chunk yet. So if you could run this chunk, just if you do want to follow along and make things work, run that. It might take a little bit to run. So remember to always load your packages in the beginning if you can. We'll talk about what packages are today. And so in this session, it's kind of a jam-packed session. We'll see how far we get. We don't need to get through it all, but hopefully we can get through a lot of it in the next couple hours. The main things we want to do is to mostly talk about data. So how do we import data? How does R store data? Talk a little bit about packages. How do we kind of get basic summaries of our data and overviews of our data? Hopefully I put in a couple different ways. Hopefully you'll learn something new if you already know how to do that. And visualize with ggplot. So I don't know if we'll get to ggplot, we'll try. And one thing to note, for this course, I'm going to focus on functions from what we call the tidyverse. So tidyverse is actually a package, but it started out mostly as kind of a, when it first was, I want to say created or imagined by Hadley Wickham, is one of the Rstudio developers and creators. He created ggplot as well. So the idea was that as a suite of packages or libraries in R that go along the same philosophical ideas, that we should work with data that is tidy, and I'll define that. And the language, the way they are used is similar. So I might talk about things like base R versus tidyverse, and base R is just how it was done originally, like the built-in way of doing things in R. Tidyverse is like an overlay on top of that uses very specific language, specific coding styles and functions to work with data. And the reason we use tidyverse, that I like to use it especially for beginners, is because it's way easier to read. I find it more intuitive. People who developed these packages worked really hard to make things make sense. It might take some getting used to, but I think it will pay off a lot. So in order to use these packages, we need to load the tidyverse package. We also, for this class, need this package called readxl, which is installed when you install tidyverse, but you still need to load it. And so I'll just note that I already did this for you, but I use kind of a not traditional way of loading packages. I use this keyload function in the pacman package. And that's because it's going to install it if you don't already have it. So I did that because some of you might not have had these packages. The more traditional way to load libraries or packages, and using library and package kind of interchangeably, is this library statement. But you only need to do this once inside of a document. So this is actually redundant of what I did up above. But traditionally, this is the way you would load packages. Another way of doing the exact same thing. So you don't really need to run either of these because we've already loaded those packages. If you ran this first, way up here, this first code chunk. And we talked about this. So the idea, here's our picture of our Rstudio project folder. So we talked about what it means to have a root folder. That's your Rstudio project folder, and how everything is relative to that folder. And so the place we want to put our data is inside the data folder that we created. We're going to use this Excel file, and we could open that on our computer, or I'll show it to you we have it on Google Docs as well. But this file lives on your computer, but Rstudio knows where it is because of the Rstudio project. So when we refer to it, we just use this, what we call a relative file path. If we weren't using projects, I would have to use this file path, this long one that includes, like, from the beginning of my file system, where that folder and file exactly are. So it's just a thing to know. It makes it easier in that way. You don't have to do as much typing. But the other thing is that if we moved the whole folder, it would all still work. It knows where everything is relative to the root folder. And so that makes it easy to share. Like I shared the folder with you, it's somewhere on your computer and it's in a different place on my computer, but everything works exactly the same as if it were here or there or wherever. So that's one reason to use Rstudio projects. Big reason, kind of the main reason. And so the way, how do we import data? I'm going to go through this and then we'll have a brief challenge that we'll do on break. So let's load in this file. So there's this function within the package that we loaded, read Excel. So here's the little help function with the question mark in front. That's how we look up what a function does and what its arguments are. So read Excel reads Excel files, shockingly. And so we tell it the way I'm going to load in data. There's lots of ways to load in data. I like to do it just with code, and that's more reproducible because we have the code. And so I'm going to run this. This is going to read in the data, and we'll talk about what these arguments mean. Let's look at this data. You can open the actual file on your computer. What happened to my? There it is. So let's look at it real quick. So there are 3 sheets. We're looking at the first sheet, BRCA. This is TCA data, so it's from the cancer repository, cancer data repository online. It's publicly available. It has tumor data. So you're going to see things like tumor stage and then survival data of that person who gave that sample, year of birth, things like that. This is publicly available, so they've consented to giving all this information. So it's a sub data set of the full big giant TCGA data, but this is all breast cancer. That's what BRCA means, breast cancer samples. And so we have this Excel data. It's in table format. One thing to notice, there's a note at the top. There's a header row. It has the names of the columns. Typical kind of what an Excel sheet looks like, right? And so if I ran this, which I think I did, yes, now we can see the BRCA clinical is here. So this is our data frame. It's telling me it's a tibble, which I'll talk about in a minute, but it's basically a data set. Tells us how many observations, how many variables. So we can actually look at it in R using this little spreadsheet looking button. If I click on that, we can now see what it's loaded into R. It looks similar, but we can see it's been cleaned up a little because there's no little note row. It's designated columns to have names. And this is nice. You can even sort by, you can sort it. This is just for visualization. It's not changing your data in any way, this filtering or anything. It's not, it's kind of like you're just observing what the data looks like. And that, what this button does is it makes a shorthand for this function view. And so this is a really handy function. I use this all the time to view data or view things I've created, data frames I've created. And you can close it and then come back to it. If I rerun this, I press the up arrow to do the code I just ran, it comes back. And so it's nice to see it in that way. Okay, so this is a challenge for you to just read the documentation and look at what those arguments do and think about why we needed them. And meanwhile, while you do that, we can take a 5-minute break, let's say 6-minute break, and come back at like 4:11, and we can talk about that a little bit more. And I will stop recording for now, or try. Okay, so some answers to these questions. For those of you that have worked with data before, I'm sure you've dealt with data that has weird Excel formats. And so all of these functions are designed, or function arguments are designed to help us deal with some of the common issues. And so this first one what does the skip argument do? If we go down here, we can see, yeah, it says it's what it basically sounds like: minimum number of rows to skip before reading anything, be it column names or data. And so we have up here skip equals 1. And that's because we had that one row of notes before it actually got to the data. And that's fine. That's one way to actually include information. It's probably better to put it in a different sheet, but that's what happens. And the other question was about the sheet, actually. And so we saw that there were 3 sheets. They were all named. The first one was named BRCA, but we can actually either write BRCA, oops, BRCA here, or 1, either one. That was the next question. Do we have to name it, or can we just use the index? And actually, that reminds me of a kind of tip that if you're not using Rstudio, you might not know. So if you have something that you want to put in quotes and you realize later, oops, that needed to be in quotes, if you highlight it and then press shift quotation, so I want the double quotes, it highlights and puts quotes around the thing that you highlighted. So that's a really, if the more you use that, the more handy it will seem. And so they had that as 1. The next question, what does the guess max argument do? And so it says maximum number of data rows to use for guessing column types. And if we want to know what the default value of that is, we're going to look at the argument tells us up here in the usage section. So it says the minimum between 1,000 and n max being the maximum number of data rows to read, and the default of that is infinity. So obviously the minimum between 1,000 and infinity is 1,000. So unless you set that row, like maybe I know my data only has 100 rows, then I'm going to put 100 there. All this is more, well, this n max is for if you have weird stuff at the bottom of your Excel sheet, or if you have really big data, it might be faster for you to tell it how many rows you have. Normally, I don't bother with that. And guess max is important because you might have, I get Excel sheets a lot where there's this weird extra column that isn't named, but people write notes in them. So like if it's human subject data and the doctor saw this patient and they commented, oh, they had this surgery, it didn't go well, we had to do it again. That might be in some extra column. And so R is going to go through your data and see that column. If it's on row 99, it's going to see that and create a column for that information. But if that extra row or that extra column point was at row 1002, it won't see it and it won't know that there should be a column. But usually I don't bother with that because I'm not worried about those weird unnamed column notes. These are things that become useful when you have kind of complicated Excel sheets or data files. Any other questions?
Jessica, there's a question in, whoa, let me pull this down. Jessica, there's a question inside of the chat, and I also have one after you answer that one.
Sorry, I missed that one. Okay, so I have a question about the skip and call name arguments. Skip equals 1 tells the R to skip this line with anything in it. Yep. And call names equals true, the default, tells it it's the first line after the skipped one that should be used for column names. Yes, exactly. And then how does the name repair argument work? Oh, I like that question because I do want to teach you that at some point. Okay, so let's pull up the data again. What did I do with it? Too many. How did I lose it? Oh, here it goes. Okay, so yes, one kind of question is that they were telling it to skip 1, and that means when there's header equals true, it's going to look for the header at n equals, or at n plus 1, right? So if we say skip 9 rows, it's going to look for the header at 10, row 10. Sometimes I have to actually like count down the rows to make sure I'm doing that correctly. or trial and error. You'll figure it out when you print out your data. Sometimes there aren't headers. And in that case, you would say header equals no. So let's say let's say this row wasn't here and only the note was there, and you didn't have any headers. That's unfortunate. That means you have to come up with your own. You can input those in R. You can name your columns in as one of the arguments, but that's a rare situation. And honestly, I probably would have just put them in myself in Excel, just because it's easier to have that saved. Usually you'll have this. We'll talk about this when we talk about working with data frames, but R is very particular about how they want their column names to look. If you've worked at all with R, and let's say you had a column name that was, let's say, primary, I'm not allowed to edit this. Let's say it was primary diagnosis with a space. R is going to allow that, but it's going to be difficult to use when you are doing data manipulation. Spaces are tricky. I'll show an example later. And weird characters, all that stuff that causes problems when we're doing data cleaning. And so what this function does for us, this is something that read_CSV doesn't have if you've used that to input CSV values, but there's a way around it. This actually has a built-in function for name repair, which lets us tell R how we want our columns to be named. And the default is unique, which means, like, let's say this happens to me all the time, where several columns have the same name, and maybe it's described what those are up in a row above it, but I can't input that into R. What R is going to do is say this is like primary diagnosis 1. Later on, if there's another primary diagnosis, it's going to be primary diagnosis 2, and then 3, and so on. So there are a lot of different ways to get around things that R doesn't like, which, like I said, are spaces, are duplicate column names, you can't have a column name that starts with a number. R is going to object to that, and it will try to fix it for you. And so this trying to fix it for you situation usually works fine by the default, but what I usually do, did I have you load? I think, yeah, it's next class where we talk about the janitor package. So this isn't going to work for you if you don't have it installed. I lost my place. There it is. But you can say name repair, clean names. That is what I usually put in mine. So those of you who have worked with R and have worked with the janitor package by chance and have it installed, this will run for you. If not, it won't. And we'll do this again. I think it's next class talking about this. But there's a function in here that makes the column names really nice. It makes everything on the same case, like all lowercase, puts underscores when there are spaces, and just tries to make them a little easier to use. So I think because these column names are so nice already, it's not even gonna look any different. Yeah, all of these are already formatted to be working well with R, so it doesn't look any different. But when we start talking about really messy data, that'll be useful. But it is a kind of a tricky argument, because if we look at it, name repair, read Excel by default ensures column names are not empty and are unique, which is very important for calling on them later. But there are other ways you can do that, and they don't even really tell you. You might have to do some digging to see what other default options are in there. So I'm going to comment this out in case someone tries to use this again. But if you want to use that and you have janitor installed, you should. Yeah, janitor is my favorite thing. I'll talk about it again later. Did I miss any other questions? Okay. So just to tell you like a little bit more about the data, there's some There's some stuff down here. So it's from the NCI, National Cancer Institute, very big publicly available data set. There's even like R packages that include this data, but it's all been processed for us. It's a little bit easier to use. And so there's this challenge, which I think I'm gonna have us do breakout rooms just to get used to talking to each other if you're up for it. And I'm going, how many? There's 15 of you besides me and Colin. So I think I'll do 5 breakout rooms. Feel free to introduce yourselves to each other and just either go through this verbally, or if one of you wants to share your screen, it shouldn't take that long. It's just filling in these 2 options and figuring out if you need to use anything, any options, and then really reading in both of the other sheets. So, all right, so hopefully everyone is at least able to get through part of this and or talk about reading and data. So one thing to note is on a lot of these, I've put eval equals false. I think I mentioned this last time. If you want this to run when you knit your document, you would change this to eval equals true. I do that because I don't want this to give you an error and stop the knitting from happening. And so this should be all very similar to, I lost the data again. The first sheet. So this was BRCA, CESC, and LUSC. The one thing to note, hopefully you notice, is these don't have a little notes on the table row, so you don't actually have to skip anything. And you can call upon these sheets either through like 1, 2, 3, or the name CESC, LUSC. I think you do have to be careful about case, like it has to be all capitalized and everything. So we do need that. So this should be CSC was sheet 2, skip 0. And so if I run this, now I can see around here, I can see I have 2 data frames or 2 data objects in here. This one is a lot shorter in terms of observations, and we can look at it and see what happens if let's say I did keep skip 1. What happens here? I'm getting some weird messages. If I look at this, now I can see that I made a mistake because I can look at my column names and see that's weird looking. It's actually that there are data that I skipped the header row. So now it's trying to make data my column names. I'm just going to print column names is the way you would just ask for the, not this one. That one. If I looked at the column names, look at all of the weird things it tried to make column names. And so when you try, if we're real column names, you'd be in a lot of trouble because these are sort of difficult to call in R when you have numbers and negative signs and all of that. Obviously that's not right, but I kind of want to show you what this NA repair does. We're trying it out. Okay, I'm running that, pretending that those were real column names and seeing what it does. So that name repair tried to get rid of anything that had a number in front. I put a little X. Anything that was missing had a column name of like ... or something. It was like ... 2. And so it's trying to fix things for me. Not reported was if you happened to have 2 column names named not reported, or 5 or 6 or whatever. It's trying to clean up my names. So in the question, what does that argument do? That's what it does. But I'm making all this way more complicated than it needs to be. So I'm not going to skip anything. Just look at it again, make sure that looks right. That looks good. And I'm just going to copy this and paste this. And so this was sheet 3. And I'm going to run that. And now I can see I have my 3 data sets and they all look good. So I'm going to close those. Does anyone have any questions during breakout room that check the chat. Awesome.
Hey, Jessica,
Yes.
when trying to import this data set was surprisingly difficult for me.
No worries.
But what I ended up doing was going under the files section there. And when I clicked on the TCGA clinical thing under data, it gives you the option to import the data set that way. Is that another way to do that?
It is. Yes, you found the special treasure. Yes, that is one way to do it. And I know I think a lot of people do it this way. And that is fine. That is definitely an easy way to do it. One thing I will say is that if you do it that way, is to save the code and put it into your document, because otherwise that's lost, right? Like this is like the interactive way. And I do this sometimes if I have really weird data and I'm trying to troubleshoot the arguments, because it gives you this option. So you can get there to the screen a few different ways, but that is one nice way, is that Rstudio that says, do you want to import this data? And so let me just show you, because it's more interactive, I can see what would happen if I didn't skip the first row. This would be the column names, and we don't want that. So what we do need to do is change this argument down here to be 1. And it's redoing it. It also tries to tell me what we haven't talked about this yet, but when we have data frames in R, all of these characters, like what kind of data type it's going to import it as. That's something to check out if you're worried about a certain column. Like if something should be a number, like an example, days default last follow-up, you would expect that to be a number. That's fine. That's maybe there's a weird something going on with that column, just be aware of. And then you can select what sheet you want, which is really nice. But now again, we don't want skip. Let me go back. Let's just do it this way, this one for now. NA by default is NA, but if you had other values for missingness, like 9999 or the word missing or a space or something, you could add those in here. But so now you can copy this. So this is going to import it. It's going to import it as it tries to give it its name, like it gives it a default name. You can edit this code once you put it in your, I'll just press import. So now it's imported it, but now we have, because I did it both ways, I have the original one I used with the code, and then I have this new one that's actually the same data. Weirdly, this one is bigger than that one. Don't know why. In terms of size, it might be just the way it read it in, but here you can see I copied that code from the interactive thing and pasted it here, because if I did want to use this later and I closed Rstudio and then I came back and it wasn't there, I'd have to redo the interactive part, which is not very reproducible. You can do that, but I would suggest not doing that. So just always remember to copy it. It also puts it in your console, so you could copy it from here too. And that's another option. It also copies the view. You don't really need that. If I did it this way, I would delete this and make sure I like loaded that package up there, and I would just keep this line in my code. That's one way to do it. But yeah, the other way to find that is, I always forget. Oh, here. Yeah, because I never use this. I always forget this button, but there's also a button here. And it gives you options like from Excel, from SAS, from text. Often, a lot of my data comes in read CSV. And so I would browse. I think there might be one in here, actually. Actually not. So never mind, I can't show that. But if I had a CSV file or a TSV file, I could open it. I think it might give me some weird error if I do this. Yeah, I'm trying to import an Excel file using import text data, which doesn't work. But I think the way you did it is actually a little better, because it knows what the data frame is. If I try to do this here, import data set, it knows to use this other package, which I was going to talk about if we had time, to read SPSS files. So that's one way to do it. And it's a little more user-friendly than just writing the code and reading the functions. Yeah, thanks for bringing that up. That's great. Any other questions? Oh, geez, it's probably really big. Now it's taking forever. Get rid of that. All right. So importing data can be tricky and frustrating. Obviously, if you've dealt with this before, it is. If you can't get it into R, that can be really frustrating. But it's probably an easier solution than it appears. But that the interactive importing is a way to troubleshoot a little bit better if you're getting some odd behavior. So there are some tips for formatting. One of the reading assignments for this week was about like how to give data to your biostatistician collaborator, basically, and just talks about the way that data should be formatted. And so the idea behind this really is segueing into this idea of tidy data. So that's another big topic I want to talk about today, is what does that mean? What does it mean for data to be tidy? The main thing is that there are like three main components. So every variable, every measurement of your data set should be a column. So if you're measuring BMI and you're measuring age and you're measuring birth date, those should all be separate columns. If you're measuring like a medication, you should have one column for the name of the medication, another column for the dosage, that kind of thing. Each observation forms a row. So every data point that you take on a person or on a mouse or whatever should be a row of your data frame, your data set. And then each cell is a single measurement. So you don't want to have like composite data inside one cell. And by cell, I mean that the location between a row and a column. So like the first row, second column, in this case is floof. That should only have one measure in it. Don't have too much information in one cell. And here's another little visual of that. Your variables or your measurements should be your columns, your rows should be your observations, and your values should be each little cell in your data set. And the reason we do this is because it makes sense, first of all. That's kind of how we think about data frame, data like a matrix or a data table, however you want to call it. So in our cancer tumor registry example, each row corresponds to a patient. So row 1 is patient 1, and that each column is their measurement for all the variables of that data. Each cell has one value corresponding to that patient and that variable. And so that is what we think of as tidy data. Sometimes your data might be transposed, which means columns are observation, like are your patients kind of, and your rows are your variables. Unless you're working in big omics data, that's not really what you want. If you're working with like gene expression data, it is actually what you want, which is counterintuitive. But in most situations, you want your rows to be your observations. And that's because you usually have more observations than you do variables, usually, unless you're working with strange big data. And so you can use transpose in Excel. That's one way to do it. You can also do that in R or Prism, I guess. I don't know. There's different ways to do that. You do need every column to have a name. Like I was showing you before, if I like accidentally read in that data as column names, there were some rows that had empty values, and so columns didn't have names, and R tried to read that in as like ... 3, or even X3 is not meaningful. So you want to name all your columns, make sure it's informative, make sure it begins with a letter, try to avoid special characters, try to even avoid spaces, and you'll see why once we start getting into data cleaning. The other thing that I have to deal with a lot of collaborators is that when you have Excel, often very tempting to color code things and have that be meaningful information, but it's really hard to get that information into R. I think there are ways now to do that, but you don't want to have to deal with that. Every piece of information should be a column, whether it's like a yes or no column or a 1, 2, 3 column denoting something that's meaningful. Make sure it's actually data, not colors or fonts or bold or whatever. And extra lines before the column header are okay, like we saw in that example. Sometimes it's just better to put that information in like a data dictionary or something. So that's usually better to do that, but R can pretty easily deal with lines at the top of your Excel sheet. Although I have had things where like people wrote notes to themselves down at the bottom of the data, and that can be more difficult to deal with, and just like you don't even see it, so it can be unexpected and cause some strange issues. And let me turn the light on, it's getting dark now. So an example of an untidy data set, just a simple one. So like I was saying, when we have something like medication, I don't know why I can't be bothered to print name, that's name. And we have two columns, one's name, one I called meds, but I put the name of my medication and the dosage and like the frequency of the medication all in one column. That would not be considered tidy data. But maybe you got data like that and you have like 4,000 rows and you don't have time to go out and separate them out into 3 columns. It's pretty easy to separate this in R actually, because it's standardized how it's added. So we'll learn how to deal with that, how to make that into 3 columns. Another example of untidy data is actually what we think of as longitudinal data. And this is a very common way to put data in to like an Excel sheet or whatever, where if we saw all these people at 3 different dates, in July, August, September, we took their weight perhaps, and it's pretty common to have these in columns, but this would not be considered untidy. I mean, this would be considered untidy. It would not be considered tidy data. And does anyone know why? Can you give an answer why that's not tidy based on our tenets of tidiness? If you put it in the chat, I'll read it. Nobody. Yeah. More than one observation per row. Yes. So these are 3 observations typically on Anna. And so we want those to be in separate rows. So this is what we think of as wide data format. If you've done data analysis as a statistician, we often call this wide data. And we want it really to be in long data format, where we'd have Anna and then a date like July, and then we'd have her value 100. And then we'd have Anna, August, 104. And we have Anna, September, NA or missing. And so those would be 3 different rows. And we'll talk about changing data from wide to long and getting it back into a tidy situation. And this, when we start, and I'm talking about this also because when we talk about plotting in ggplot, this can be harder to work with. Long data is often much easier to work with ggplot and other plots, plotting situations. All right, any questions? This was the paper I was talking about, organizing data in spreadsheets. It's really well written and talks a nice, succinctly about how to organize your data, or how to try to convince your collaborator to organize their data. And this is the opening sentence. Spreadsheets, for all their mundane rectangularness, have been the subject of angst and controversy for decades. And it's true, everyone has their own idea of how to deal with them, but there's still not real consistency in how people do use them. And so that's what this is trying to do. It says that we want to make it so tidy data sets are all alike, so we can use R and code, use the code on in the same way on multiple different data sets. But each of them probably do have their own kind of messy issues. And so we kind of, when we do data cleaning or data wrangling, that's what we're doing. We're trying to get those into the tidy way. All right, so having said all that about tidy data, how do we use data in R? The main data type for a data spreadsheet or data table is called data.frame. So for last week, we talked about vectors. Here, we're going to talk about data frames. And so by definition, a data frame is like a rectangular table made of vectors of all the same length. And so just looking at, let's say this one, here we have a rectangular data set. We each have many columns and they all have the same length. They're the same number of observations, whether we have missing data or not, that's fine. But this is a rectangle basically. And so that is how R stores data. It's a data frame. Each of these columns can have different types. So we talked about numeric, logical, character, factor. We haven't really talked about factor. There's a lot of different column types, factors or dates as another one. The most common one, especially that what we use right now, is numeric and character, but you're allowed to have different types. I saw that a little bit in that interactive data importing window. And so this is a very useful way, a versatile way of storing information because of that. Though note that since we're using the tidyverse and we're using read_Excel function to get our data in here, tidyverse made something called a tibble, which is, we can see here, TBL_DF. That's the type. That's if I type class of BRCA clinical, that is the first class that shows up, TBL, and so they pronounce that tibble. That's really the same thing as a data frame, but with some perks, kind of. And it's basically affects how it prints. When I just type BRCA clinical out, I want to see what it looks like here in the console. It cleans it up. If you've worked in base R and you use just regular data frame, you'll know that if I did that and it was a regular data.frame, it would print all the rows, which can be annoying. And so a tibble, think of them interchangeably if you want. That for all intents and purposes that we work with, they are the same. They do the same thing. It has so many rows and so many columns, and it has variable types. These are characters, ethnicity characters, somewhere. Days to birth is a double, which means a numeric value. So we're getting some information about it. So I'll say, sometimes I'll say data frame, sometimes I say tibble. I basically mean the same thing. Read_CSV is another function that you might use to read in CSV files. That also creates a tibble. It's all in the tidyverse atmosphere. I don't know. So how does what can we learn about our data now that we have it in R? Remember how I talked a little bit about objects and they're stored in our environment. You can see them in our global environment. These are telling us all the things that we've run and defined, and it's giving us some information. In this case, it's giving us right here down in the environment tab, how many rows and how many columns. But we can also get that information in code. So the dim function here, dim, tells me rows and columns, the number of rows, number of columns. There's also ncol for if we want to know the number of columns, and row. This usually is something that is just you print out just to look at, but sometimes you might actually need to pull that information out. So that's one way to do it. And some basic stuff. There's the head function, which looks at the top, I think 5 or 6 rows. Yeah. And that's like the head of your document or the head of your data. And so when you're running it in the RMD, will give you this nice little table that you can navigate. But that's really just printing 6 rows at the top. There's even correspondingly tail, which I hardly ever use, but it is useful to know if you do have strange stuff at the bottom of your Excel sheet, and that will tell you, because it will show you like all these missingness except for a couple words somewhere. So just be wary of that. And so what happens if you type, I just did this, so I'm not gonna make you think too long about it, but if you type that in the console, this was exactly, where was it? Oh yeah, head. So you can see the printing looks different in the console than it does in the RMD. RMD gives us this nice like interactive, you can scoot over to the other columns and things like that. But in actuality, the code itself looks like this when it's printing something. In the console, it tries to truncate it so it doesn't take up too much space, but it's all there. This is the name of our data frame, and it contains all of the information. It's just not showing us everything when we print it. It's trying to make it easier on the eyes, I suppose. And I showed you this, so you can pull out the column names. Call names is the function, and that gives us the column names. You can see them a little easier. We can do the same for row names, but there aren't any row names on Tibbles usually, so that's not really that useful. We can just look, just a bunch of numbers, not informational at all. The functions that I use a lot are glimpse. So I'll run glimpse just so you can see. It tries to put all of your columns down one after the other, and it shows you the first couple, 2 or 3 observations. I do this just to get a sense. Like I was pointing out that, which one? Oh, that's interesting. So I noticed when we were doing the importing with the interactive way that it was trying to make this a character vector, and I wonder why. I think that's probably the difference in size. Might need to do some examining, but this did read days to last follow-up as a double. And so I just use this to kind of get a visual on what this data looks like, how many like I can see, oh, there's obviously some missing data here. But you don't get that much information, but it's a good like overview. So glimpse is useful. I showed you view. That will open it up like this in a little spreadsheet. Glimpse, like I said, is useful to see what kind of data we have. We have characters, we have doubles, which is numeric. So identify the numeric variables, they're noted as double. So for example, year of death, which starts out with a lot of missingness, is a double. View. The other thing I did show you, this is class. So if when we were talking about vectors, class of, let's say my vector is 1 to 10, class of a vector, you get to see what kind of data type it is. In that case, it was an integer. And it's a similar idea for a data frame. It's usually going to tell you that it's a data frame, also a tibble. So those are all the things that it is. It's multiple things at once, which is kind of funny. So we're gonna not actually do any data manipulation in this class. We're gonna do that next week. I'll show you how to filter and manipulate and change your data however way you want. But for right now, if you haven't worked with R, the one kind of simple way to just pull out one column is by this $sign. And we don't actually use that that often in this class because there's a little more simpler, kind of easier to read way to do that in the tidyverse. This is what I would call a base R way of doing things. But it's a quick and dirty way to just pull out a column. And so notice that it printed every single one. There were like 1,000 some odd values of that vector. Actually, it gave up at 1,000. So that's nice. One thing you can see though, by actually looking at the data, is I noticed this says not reported. So we might actually want to include that as an NA. And when we talk more about dealing with missing data in our data frame, I'll show you how to turn that into NA. But for now, you can do this if you want. I don't recommend it really because you can't, it's just not much you can do with all this output. But we are going to use that, I think, in a later section of this. So just so you know, that's one way to do this. And then, yeah, so for summarizing, last bit I want to talk about for data frames, the kind of simple way of summarizing your data is using the summary function. And this is useful if you want just a quick idea of what your data looks like. Though if you have a lot of character vectors, in which case we do, you don't get any information about those, unfortunately. But you do get to see for your numeric ones that you get kind of a 5-number summary, sort of min, mean, max. You don't get standard deviation for some reason. but you get some information. So that can kind of give you a clue as to whether your data is making sense or not. Tells you how many missing data points there are there. So that's nice. It's not perfect. If you had factors in your data, which we'll talk about what factors are later, basically like categorical data, it might tell you the counts in those categories. So I kind of run that. I usually run glimpse and summary at the beginning when I'm doing data manipulation, just to see what it looks like. But there is another useful package. So I sort of went kind of quickly through the idea of packages, but packages basically are like libraries that someone wrote that includes a bunch of functions related to a theme. So in this case, this package is named skimr, and it tells us that this is going to define functions that are related to what they call skimming, so kind of summarizing the data. And so up on the top code chunk, the very first one, I forced your computer to install this. If I hadn't done that, you could install the package using the install.packages skimr statement. There's other ways. You could actually go into the packages here and click the install. So multiple ways to install packages, but you only need to do that once unless you want to update it later. So I wouldn't recommend putting this in your RMD. I put eval equals false because I don't want to install it every time I knit this document, just as a kind of a reminder that you can install packages this way. But I kind of took care of that for you in my code up above. But this is a really useful package because the function skim is kind of like summary, but it gives us way more information. So it's hard to see sometimes though. So what this did is it separated my data into the type of values it is. So we have all our character value columns here. It tells like how many are missing, how many categories there are, how many unique values there are. We can see there's 1,095 unique IDs, which is precisely what we want. There's 13 different kinds of tumor stage. And so that's all useful information. And for numeric values, it gives us those 5 number summaries, but it also gives us standard deviation and like a little mini histogram. So we can see days to death, for example, which is the second row of this output. We have a lot of days to death on the low end, which means that data is kind of skewed in that it's skewed towards the low end of that value. Whereas something like year of birth, a little more normally distributed. What's this one? Number 3, days to birth, a little more normally distributed. So just a quick, like very brief summary of your data, which can be really nice for looking at it. And then the other 2 more things before we go on break. VizDat is another very useful package. VizDat has this viz_dat function. So this is the function in the package called VizDat. And if we run that, we should get an image that tries to show us some things about our data in a visual way. So first of all, it tells us which ones are characters, which columns are numeric. And it also tells us about missing data. So the gray is missingness. So you can see days to death and year of death is often missing. But if we think about that, that's because not everyone has a year of death. Not everyone, most people looks like survived, which is good. So just kind of like, it's a good thing to get in the habit of doing is don't just read in your data and then carry on your merry way doing some linear regression or something. You need to be able to see and anticipate weird errors or kind of oddities about your data before it happens. You'll also be very confused later on. So always do some kind of summary of your data. It's really helpful. And these are making it a lot easier. And then the last one, I threw this one in because I want to show you how to use this later. But in the most simplistic way, GT summary is a package that has a function called table summary, table_summary. And if I run this, it takes a minute. You'll see why. I'm using this in a way that I wouldn't necessarily use this because we don't have the tools to make it a little bit better. I'll explain what I mean. So we're looking at this output. It has each column, the first one being submitter ID, and then it tries to make a table or a summary measure out of that. So for any character data, it's going to give me counts. It's basically a table 1 if you've done any kind of ethnology research or statistics research. It's giving us the information about our cohort. And so I wouldn't print out, obviously, the table of my IDs. That is silly. And I'm gonna jump ahead. What's it called? And get rid of that just so you can see it a little better. I'll talk all about that code next week. But for now, just because that's messy, I got rid of that column, and we can see for primary diagnosis, most people had this C50.9 diagnosis, 99%. We can see all the tumor stages. This not reported line item shows up, something we might want to be aware of. Everybody had breast cancer, proportion alive, 86%. So this is, and again, like morphology has a lot of different values. So this is a quick way to get like a table 1 or a summary of your cohort, which is very useful. And this package is super powerful in terms of summarizing regression output or statistical output. And I'll talk about that at some point as well. And we'll use this again for once we know how to do this a little easier. All right, I think that's all the summary stuff I had. Okay, so before we get to ggplot, let's do another 5-minute break, and then we'll have a very intro ggplot time. And I will pause for now. Okay, so the last thing I want to talk about is ggplot. I'm sure some of you have experience with ggplot, but I think this is something that can be intimidating, especially for people who are new to R. And I'll admit that even when ggplot was first invented, I don't know, 10 years ago or something, I didn't use it for several years because I was convinced that I could just do everything in base R plots. But then once I got over it and started learning about it, I realized how powerful it really is. And so I think it's worth the initial struggle and kind of getting used to the somewhat strange syntax, because it is a lot easier once you're used to working on ggplot code. I lost my chat. Okay, so let me just move to the slides again real quick. So again, this is an intro. We're going to only do very basic stuff. So if you've already used ggplot, this is going to be a huge review. But I want to get everyone used to using the syntax. And then later we're going to do all the fun advanced ggplot stuff, because that is half the fun of coding, is making nice visualizations, and we can do that. So ggplot2 is in the name of the package. This part is confusing because it's called ggplot2, but the name of the function is ggplot. Keep that in mind. So it's a way to visually explore data, to make really nice plots, make publication ready plots, to make interactive plots, lots of things you can do with ggplot. And ggplot is based on what's called the grammar of graphics. So that's the GG part in ggplot, grammar of graphics. And so there was many years ago, whoever kind of wrote about the grammar of graphics, many people have, but Hadley Wickham, who designed the first ggplot package, incorporated those tenets, which basically means that the way we talk about visualizations, we think of it in terms of a language, just like we think of R as a language. And the way we talk about plots and graphics is also a language. And so ggplot, first of all, does a lot better when you have tidy data. So make sure your data is tidy. The second part of ggplot is this idea of mapping. And so we're always mapping elements of our graphic to variables in our data set. So when we say variables in our data set, we think of columns in our data frame, or tibble, whatever. And so we might have the x-axis is one column, y-axis is another column. We might map color the color feature to another column. We might map size, as in like the size of your dot or your point, to another column. So that's what we think of as mapping. And when we see the code, the mapping goes in the aesthetic, the AES function. I'll show you that in a minute. And then the third aspect that we'll talk about today is the geom, or geometry. And that defines the type of plot that you're making. So geom point means that we're making a dot plot, a point plot, like a scatter plot, essentially. So we tell ggplot 3 main things in order to make one simple plot. We need to tell it the data name, the tidy data name. We need to tell it the mapping, and we need to tell it the geometry that we want. And so looking at the code here, introducing ggplot, Ted has a little video here if you want to watch his intro and hear a different take on things. That's just a nice picture. Where is this? Okay, so right now we're going to work towards making this graph. Let me minimize this, which is a scatter plot. You can see it's a scatter plot of age at diagnosis in our BRCA data with days of follow-up, days to follow-up. Should be days of follow-up probably. And these are numeric values on the x-axis and the y-axis. We also have gender as a binary variable. Of course, not always binary variable, but in this data seems to be perhaps self-reported. And so we have just a few people who have reported as male in this case. So breast cancer, that makes sense. And we have a lot of data points that we're seeing here. And then we also have a title, age versus days to last follow-up. So this is what we want to accomplish. And this is that mapping geometry figure. So keep this in mind as, keep this in mind as we build our code. And so, like I said, GG is short for Grammar of Graphics. And the way we read our ggplot code is we start out with the function ggplot, which we then put the data name here. We also need this really hard to remember function name called AES, and AES stands for aesthetic. I don't know why they didn't just call it like mapping or something. I don't know. I think that was a poor choice, but we have to remember this, AES. And that is where we put the mapping from our x-axis to age of diagnosis, our y-axis to days of birth, and then geometry. And all of these are connected by the plus sign. So they're all chained together, ggplot plus the aesthetic plus the geom point. And the AES function is very important. All of these are very important. You can't make a plot without having these 3 things. You can add on a lot of other stuff and a lot of other layers, but these are the 3 basic things. But I will note, because we're learning about ggplot, and some of us are very new to this, that this AES function can be in 3 different places. You can put it inside ggplot. So I would do comma, AES, x equals whatever, y equals whatever. That's the way I usually do it. For this kind of educational purposes, we took it out and put it after the plus sign. The third place it can be is actually inside geom point. So when you're reading other ggplot code, just be aware of that. It might be confusing at first. It's probably going to be confusing for a long time. It's an important part, but you need it to be somewhere. It can be in here by itself or there. That's a weird thing. I didn't even know it could be outside of ggplot for a really long time. So I learned something new when I first started teaching ggplot, because that was odd to me. And so for a scatter plot, it depends on what geometry you're using, obviously, what kind of mapping you need. For a scatter plot, you need an x-axis and a y-axis, right? You need the point needs to know where to go. And if you don't define that, R is going to complain and say, where's your X? Where's your Y? So I might show you. There is I taught a workshop with Micah Niederhausen on ggplot. That's not what I want. But, there's a link to these slides in the markdown. It's been almost a year now since we taught this. And I actually think it was 2 years. Wow, I think this is the first virtual one we did. And so this has a lot of ggplot examples. I like this one. I just want to show you how things build. Don't worry about understanding every line of code. This is a visualization exercise for now. Later, we'll talk about what each of these things do. But we want to get going away from our scatter plot for just a second. Let's say we want to build this really kind of busy plot where we have box plots and violin plots and jitter plots and a lot of information, probably too much information, but let's say we want to do that. I just want to show you what happens if you only type this into R. ggplot data equals, in this case, we're using the Gapminder data set. It's a different data set than our RMD one, but just keep that in mind. It has data on countries and country like GDP and all that. If we just type that into R, it says, okay, you want to make a plot. And here's your blank plot. That's all it does. You get this blank square. And so then if I add my aesthetic, my mapping, and I say X equals life expectancy in years. Oh, and then R says, okay, cool, you want a X-axis. I'll make you an X-axis, but I have nothing to plot. You haven't told me what kind of geometry. Like, what do you want? Do you want a box plot? Do you want a scatter plot? What's going on? So that's where the geom box plot comes in. Don't pay attention too much to the alpha. That just tells us how dark and shaded we want it. There's going to be a lot of options we'll talk about later. But we can see now that it's added a box plot of life expectancy in years. And so here we could be done. That's our plot. That's like the most simple plot we can make with that one variable. We can see the medians like 73 and the IQR interquartile range is like 65 to 78 or something. So we get a sense of what the data looks like, but we could keep going. And so the idea behind ggplot is this addition of layers. So you add a plus sign, and let's say I want to add a y-axis. So I just added my y-axis. 4 regions are Africa, America, Asia, Europe. And now it's separated my box plot into 4 groups. And now we have 4 of them. And so that's the power of ggplot, is you can keep adding on layers, as we call them, to do things. Here I added in a color, a fill. I filled my box plots based on the 4 regions, mostly for aesthetic reasons. We'll talk about ggplot themes, but this next layer makes a theme or uses a theme that makes our plot look different. So you can see before the theme was added, after the theme was added, this is actually from a package 5 that makes 538. If you know that website, they have a certain style of plots. So if you have a specific style you like, it's pretty easy to change it like that. We'll talk about colors and how to change our colors, but you can see my colors changed based on the scale of my fill. We'll talk about all these advanced things later, but I just want to show you that adding in these things in pieces, like a title and a theme and a legend position, and then we added on another geometry, which is like a dot plot, but we call a jitter plot, and then we can add on another geometry, which is a violin plot. So we're showing 3 geometries at one time, all from the same data frame, same tibble. We've defined it, and we've told ggplot all the little kind of nice characteristics we like about our plot, colors, and all that. We change our axis titles and main title and so on. So you should get used to using the adding symbol. This is I think the only time in R where we use this plus sign like this. So it's a very particular way of coding. That part gets getting used to, and get used to using the aesthetic and the geometry. Usually the function name is kind of self-explanatory, like geom violin is for a violin plot, which is this mirrored density plot here, this little curvy thing. It's showing me like the curved histogram, the density of the distribution of that data in a mirrored way, if you haven't seen a violin plot before. But so when we talk about ggplot again, we'll talk about all of these, but I just want to show you that this kind of layering situation gets you some pretty sophisticated plots. And in these slides, goes, okay, it's not as close as I thought it was. But there are a lot of, here, this shows you all the ones that are in these slides. So if you are interested in looking at these, the workshop's also recorded. If you look at this and say, oh, I do want to learn how to make a smooth plot, this might be a nice way to see some examples. So the slides are at the bottom of that markdown, I think. So let us just have like a 3-minute on your own challenge. So I've shown you the basics of ggplot and what you need to put in the code. And so how about you try just basically fill in these blanks and get this chunk to run. You do want to change this to true if you want to see it later in your ARM markdown. And because and that's one thing to note is I changed this to true before I fixed the code, and R is trying to tell me those aren't going to run. That's not, this is what this little X means. So that's the part you need to fix. So at 5:28, we'll come back and do it together. All right, that was probably hopefully enough time to plug it in and play around with it a little bit. So the idea was that we wanted to recreate this somewhere up here, this scatter plot. And so what we need to know is what is defining our x-axis and what is defining our y-axis. Oh, good question. I'll answer that question in the chat in a second. So here we can see that it's been renamed, but we do need to know what column names those are attributed to. So let me look at this again. Oops, did not. So we can see age diagnosis is age_at_diagnosis. And then the other one, what was it? Wanted days to last follow-up, which is here, days to last follow-up. So you need to use the column names here. I'm just going to copy that, cheating a little bit because it's down here. And it should, no, I don't want to enable Siri. Days to last follow up. Okay, so if we run this, here we can see the output down here. The question in the chat says, should the plot also display under the plot tab? I think it doesn't do that by default. There are, so I'll say that when you're working in an ARM markdown, the default way is to put the plots down here. If you want to show it in the plot tab, if you copy it and then paste it over here, it does show up here. There is a setting in the ARM markdown. I have to look up the file because I forgot. I wonder if it's in here. No, setting somewhere. Yeah. You can change. Okay, so what I did was up here, there's a knit button, and then there's a little gear. And there's some options in here you can mess around with. Chunk output in line is the default. And I think if you push chunk output in console, it's going to put all of your output over here in your console, which you may or may not want. I know some people prefer that. But I think when you're working in RMD, by default, it's down here. If you're working in a .r script file, which isn't a markdown file, it's just R code, the plots will show up in the plots panel. I guess like a side note to that is if it is in the plots panel, one way to save it is to use this export button, and you can save it as an image. But there are other ways in code to save it. So you can play around with this. Sometimes I do this just in a fast pinch kind of way, just to save a quick plot. And other things to note about RMD is if I couldn't really see this and I wanted to make it bigger, there's a little pop-up button, and it will make it in a different window just to look at it. And when you resize it, it changes a little bit. something to keep in mind, the size of it. Oh, it's just being slow, but you can see your output in a new window. Yeah. Yeah, it's sort of weird that they have this, but it's not always used when you're in Markdown. Okay, so this is, we're getting there. We have a plot and there's some dots. That's a good start. One thing though is looking at the x-axis, it's like thousands. That's obviously not a normal age. So that's because age is in days, not years. So let's just add in this divided by 365 to get a quick translation to age in years. When that is allowed, you can actually, sometimes this happens where, yeah, okay. Sometimes it happens where you run it and it doesn't show the output, and I can never figure out exactly what causes that, but just sometimes you might need to run it once or twice. So now we see that in the x-axis, it's in years, and it tried to tell us what we did. It added in that 365 divided by part. And so that is basically the plot we want, but now we want to add in all the little features. The other mapping that we had in the original plot was color. And so we can map the column name gender to color. So in the aesthetic, we have X, Y, and that's also where we can put in color, or later we'll use things like fill or shape or line type, I think is another one. So I'm going to say the column name, color, and notice that I'm not putting quotes around my column name. That may be intuitive to you or not, but we don't need quotes. You just want the straight name of your column name. Same with the data. The data is just the name of the data frame. And then the mapping aesthetic function just uses the name of your columns. So let's run this. Okay, so we can see it's given us colors and it's given us a little legend by default. All of this is customizable. I can change the name. I can change this to sex, which is probably actually what it is. And I can change this to something, which we're going to do in a minute. And you can change the colors to not be this kind of weird tangerine red and teal blue, which you get quickly very tired of when you make a lot of ggplots, because this is like the default color. But for now, we'll just do the kind of simple stuff here. I'm going to change this to true. That's actually what the problem was. Probably. No, never mind. It was just unusual. So titles. There's actually different ways to add in a title and x-axis labels and all of that. So you may have seen other ways of doing this. GG title is one, X lab, Y lab. But kind of the more efficient way is to use this labs function. So again, we add on essentially our layer with the plus sign, and then we use the function labs, and then title is the argument. So let's actually just look at question mark labs. It gives you some options, so we can see what we can, different things we can put in here. In the function labs, we could have a title, we could have a subtitle, we could have a caption, we could have other things which are not listed. That's one thing to kind of realize about R is that whenever this is an argument, this ... that means there might be other arguments allowed that it's not telling you. So that's one frustrating thing I find about some of the documentation is you kind of have to go on a scavenger hunt to figure out what other options there are. So I'll show you. This is just adding the title. So we see now age versus days to last follow-up is now our title at the top of our plot. That looks good, but I don't like this. I don't like these kind of underscore column names. I don't like that. So I want to change my x-axis. So X and Y are possible arguments, but the documentation didn't tell me that. I don't know why. I think they're really just trying to make it general. So basically that's saying the name should be in the aesthetic, which means I could say color equals sex. Let's see if that works. And that has changed the name of my legend. And this has also changed the name of my x-axis and my y-axis. Looks a little nicer. Subtitle, maybe we want to do subtitle. My nice plot, I don't know. And here we can see it added a little miniature title below the big title for a subtitle. So you can add a lot of things in this labs function. That's kind of a useful way of just putting it all together, other than you can separate it out using other functions, but I like to teach it this way just because it's nice and concise. So we have a plot. I made it even fancier. What if we want to save it? I showed you one way to do that is if you run it in the console and get it in your plot thing here, plot pane, you can do the export function, but actually there's a actual R function called ggsave. And if I run this, it's going to save the last plot that was created. So here, it saved it. And if we look in the files, because we're in our Rstudio project, it put it in our main part 2 folder. And I clicked on that, it opened it up. And here it is. You can also customize ggSave, like see what other arguments are here. So you can do width. I think it's usually in inches, height equals 5. Let's try that. So if I look at that now I have a weird kind of wide plot. So you can imagine like creating publication figures, you have specific height measurements and stuff that you want it to be. And so there's all of that is customizable. Something we'll talk about next time, note this warning. Like I said, warnings are usually more informational. You don't need to worry too much about them often, but they do give you some clues about what's happening. It's telling me that it removed 120 rows because there were missing values. So what that means is maybe days of follow-up had some missingness or age, and so it couldn't plot a point for that person because there was missing data. And so there's ways to deal with that, but just something to be aware of. Not all of your data is shown here because some of it is missing. Any ggplot questions? I think your assignment has one very short ggplot question, but we gave you some kind of scaffolding so you know what we're asking. But so basically when you see something like this, that means replace that with the right thing. And then that's this part, but then there's also one that asks you to make a scatter plot slightly differently. So I only really showed you how to do a scatter plot, but we'll do histograms and bar plots and all of that later on, many kinds of plots. All right, so the last part is optional. I just want to mention it and we can close a little bit early. I showed you actually when I was doing a quick example that you have other data in here. You have SAS data, SPSS data. I wish I had put in a CSV file. But there can be lots of different data types. R has a package called Haven, which will let you read in SAS data or SPSS data or Stata data. And you can use those at your whim with some caveats. Like if anyone has worked in SAS or Stata, you know that there's some extra stuff in there. Like for, I think, actually, I don't know, does SPSS, I think most of them have what we think of as labels, depending on if you worked in Stata or not, or they save essentially categorical data differently, right? If you've worked in those softwares, sometimes they'll have like, let's say, race is a categorical variable and usually in the data, and it might save that as a numeric data for 1, 2, 3, 4, 5, and then map those values to the words like African American, Hispanic, etc. And so that is usually stored differently. So it's just something to think about when you're doing this. You might run across that problem. There's a whole vignette about dealing with labels. So there's a link here if you run across that issue. We're not really going to do that in this class because most data that you'll come across will be in like an Excel file or CSV file, but statisticians often like to trade data from different sources. And so knowing how to do this is useful. we haven't talked much about factors, so I don't want to get too far into this, but read this section if you do want to import data, and feel free to ask me about what they do if you have that challenge. And there's some other links about learning more about Haven. And that's a relatively new package too. Previously, it was a lot more difficult to get. It was actually more difficult to get Excel data in R. So a lot of these newer packages have made things a lot easier, getting SAS data in and Stata data and all that. So I am appreciative of these people who developed these packages. Okay, so basically what you learned today, we talked about loading in Excel data. There's, as we saw, a couple different ways to do that, the more interactive way or the coding way, but either way, save the code that does it, because in terms of reproducibility and this idea of like what is real, as I was saying, your code is real, the data file is real. So keep all that code there, keep your importing code so that you can use it later. So we know about data frames and tables and how they have columns that are meaningful. We're gonna next week work with a lot of data manipulation and data cleaning, which is something we as statisticians spend a lot of time doing, and yet somehow no one ever teaches us how to do that. So I think that's gonna be really useful. And then ggplot2, very basic grammar of graphics usage. I think it's something that if you haven't used ggplot, then it's going to be tricky. And that's why I wanted to do the simple version right now, because I think having practice on your own, struggling with it, take some time to struggle with it and read the documentation. And it will become more easy to use the more you use it, definitely. There is this little, I don't know if any of you have seen this, our boot camp. Ted mostly developed this, but I developed a couple chapters. There's a Magic of ggplot, our bootcamp link, so you can read a little bit more, practice. There's some like little practice code in here to fill in. So that's a very short and quick way to practice your ggplot skills if you're new to it. And like I said, the link to that, our bird workshop that we did, ggplot is there, but when we talk about ggplot again in class, I'll do some more advanced examples as well, but there's a whole slew of examples in those slides. All right, so there's the part 2 as assignment is in here. I haven't put it up on Sakai, like the Dropbox or the whatever it is, submission thing. If anyone has had trouble submitting to Sakai for assignment 1, which is due almost at midnight tonight, let me know. It can be finicky sometimes. And assignment 2 will be submitted the same way. You're welcome to submit your RMD, but you don't really have to because of this echo option, which prints out the code for us so we can see it in the HTML. The bare minimum, submit your HTML. If you want to submit your RMD as well, you're welcome to do that. All right, I think then we will end a bit early, and let me know if you have any questions in the meantime, and I'll see you all next week.
Thank you.
Thanks.